So for results of inductions are the EIF induced. So this is what is a magnetic coil. So this is a passing through the magnetic flux. So when the magnetic flux is changing, so in this case, a voltage induced in the this is induced EMF. So the EMF is induced in the loop. When the number of magnetic field lines step up to the loop is changing. So the EMF in the loop is induced. And EMF is induced in the loop when the passing flux is changing. So this is what is Faraday law. So when the electric magnetic flux, the flux are passing through the loop length. The flux is changing, so the EMF will be produced. So therefore, we can calculate for the flux phi. Flux phi is the integration of the flux density multiplies the area. So this is for the flux phi can be calculated. The integration of the flux b vector and the area vector. So this is the we got. So we can calculate for the phi. Phi is equal to b multiplied a. So this is for the phi. Phi is equal to b into a. So this is for the flux. In the meantime, induced voltage can also be calculated. Induced voltage E is equal to induced voltage E. So E is the induced voltage. Can be calculated minus n d phi by dt. So n is the number of terms. And d phi by dt. So this is the rate of change of the flux. So E can be calculated as E is equal to minus d phi by dt and d phi by dt. So rate of change of the flux multiplied with the number of terms. Then we can calculate for the induced voltage E. E is equal to n d phi by dt. This was the long solenoid coil has a 220 turns per centimeter. It carries the current either 1.5 ampere. Its diameter D is 3.2 centimeter. And then at the center of the 130 turns are the womb. The coil meter is 2.1 centimeter. The solenoid is reduced to the 0 at a steady rate in the 25 milliseconds. What is the induced EMF? Firstly, we have to calculate for the flux phi. Flux phi need to be calculated, flux density multiplied area. So flux density is we can also calculate mu 0 in the n, mu 0 into the h. Mu 0, so mu 0 and multiply with a. So the flux density can also calculate 4 pi into the mu 0 4 pi into 10 power minus 7, and also there's a mu 0 I into area A. So that we can calculate mu 0 is 4 pi into 10 power minus 7. Current is 1.5 ampere flowing. The current is 1.5 ampere. And number of turns is 220 turns per meter. But if for the length, to the length we will multiply with 100 meter. So that this is 220 turns per centimeter, and multiply with this is for all the units are meter unit. So 220 turns per centimeter. Multiply with 100. So by this is what you got to do this. This is the turn per meter. So 4 pi into 10 power minus 7 mu, and also current, and then also the multiply with the area. And then you can calculate area is 5 by 4 into d squared. 5 by 4 and d is 3 by 2 centimeter. 3.2 into 10 power minus 2 meter square. So then by solving this one, you can calculate plus. So the plus will be 1.44 into 10 power minus 5 wave. So this is the size 220 term per centimeter. To get a term per meter, you have to multiply 100, and then you will multiply with the current, multiply with the mu0, and area. Area is a pi into the diameter square. So you got an area, so you got a plus by 1.44 into 10 power minus 5 wave. So in this case, the fly is changing from the 0 to 1.44 to 0 within the 25 milliseconds. So first we calculate the d phi by dt. 0 minus 1.44 into 10 power minus 5 divided by the 25 into the 10 power minus 3. So by solving this one, what you got the same thing. Minus 5.76 into 10 power minus 4. So this is for the both parts are done. So E can be calculated. So this is the E is minus n d phi by dt. So minus number of times. How many number of times is it? Total number of times is 130 times. So 130 times multiply with. So this now 130 times multiply with the d phi. D phi is 0 minus 1.44 into 10 power minus 5 and dt. So d phi by dt is we already got it 5.76 into 10 power minus 4. So minus 5.76 into 10 power minus 4. So then we got the input voltage that will be the 75 into 10 power minus 3 volt or 75 millivolt. So by the way we can produce the voltage. Okay, the next topic is the Lenz's law. The Lenz's law means the induced current has a direction such that the magnetic field due to the current opposite change magnetic flux that induce the current. So when there's a magnetic flux direction and the current direction, the magnetic flux induce the current. So the induced current direction and the magnetic flux are usually the opposite direction. So this is the Lenz's law. We can also calculate the energy. Energies are produced by this is the energy. So magnetic energy. Magnetic energy. So magnetic energy can be calculated. So that this is a 0 to the I into GI. So this is the magnetic energy. A is the inductance, I is the current. So integration 0 to I, LI/DI. So that will be the magnetic energy is U is equal to half into LI squared. So magnetic energy can be calculated by equation U is equal to half into LI squared. So in this case, U is the magnetic energy, A is the inductance, and the I is the current. This program equals has inductance of the 53 millihenry and resistance at 0.35 ohm. So if the 12 ohm is applied across the coil, how much energy is stored? So firstly, you have to calculate the current I. So I is equal to E by R. So voltage is E is a 12 ohm. Resistance I is a 0.35. So then you can calculate the 34.3 ampere. So this is the current I. So after you can calculate current I, you can also calculate this magnetic energy U half Li squared. So half multiply, it is already given as 53 millihenry. So 53 into 10 power minus 3 multiply current 34.3 squared. So by solving this was magnetic energy wave is 31 joule. The magnetic energy is 31 joule. So this is for A. And the B. So another thing is that we also have to utilize pay out the half of the value. Half of the value means that half of the current value has to be reduced. So the half Li squared. Half Li squared is equal to this is the half of the half Li squared. So this is what the energy is half of the energy. So half of the energy can also be calculated. Then we just this height here. So I squared by 2 into L. So this becomes half into I by root 2 square. I have root 2 square into L. So current value need to be reduced by root 2. So current value need to be reduced by root 2. So therefore we write down the equation. Initial current I0 into 1 minus e power minus t by tau is equal to the current value is I0 divided by root 2. So current value need to be reduced by half. So therefore we can write up here e power minus t by tau is equal to 1 minus 1 by root 2. So 1 minus 1 by root 2 with 0.293. So we can now use as a minus t by tau. So L as 0.293. As 0.293, so that now you can calculate for the tau. So time constant from here you can calculate. So that L as minus 0.293, then we can calculate for the time constant. Another one is the capacity load. So this is what the magnetic field for the capacity load. So this is for the alternating voltage, and this is the capacitor, the current IC flowing. So this is the voltage VC. So in this case, you can also calculate current IC as a dQc by dt. Q is a capacity charge. The capacity charge divided by dt, so you can call the current I. So VC is also the you can call the VC size omega t. So therefore, we can also calculate IC. IC equal to is omega c VC cos omega t. AC capacity reactance 1 by omega c. So those are the equations for the capacity current and capacity load for the capacitor. Capacitance C is a 15 microfarad and the sinusoid is ACE and a device. Operates at the amplitude E as 36 volt, frequency 60 Hz. So what are the potential difference we see across the capacitor and amplitude VP or the VCT? So in this case, the maximum voltage VC equal to E maxima is only given at 36 volt. So this one you can write down the equation. VC is with the time function is equal to E with the time function. So this is the EM psi omega into T. So in this case, EM is 36 psi omega into T. So omega is now given the frequency 60 Hz. So this is 60 is 2 by f. So omega equal to 2 by f. So 2 pi into f is 60, you will 120 pi. And therefore the VC T is equal to 36 psi 120 pi T. So this is the equation for the voltage for this problem. And the B. What are the current ICT in the circuit as a function of time, the amplitude IC of the ICT? So there's to find the ICT. IC equation is here. IC is equal to IC psi omega t minus pi. Or IC psi omega t plus pi by 2. So this is the equation for the capacitor. So in this case, to calculate the IC, we have to calculate the AC, capacity reactance. So capacity reactance 1 by 2 pi is SC. So in this case, 1 divided by 2 pi is 3.1416, frequency 60, as capacitance. Capacitance is 15 into 10 power minus 6. So 15 microfarad, so 15 into 10 power minus 6. So by solving this one, the AC is 177 ohm. So the IC can also be calculated VC by AC. Now VC by AC is VC is 36, AC is 177. So we solving this one 0.203 ampere. So the IC into T can also be calculated 0.203 size. So 120 pi T plus pi by 2. So this is for the ampere. So this is the way we calculate for the current and the voltage across the capacitor in the circuit. Magnetic center electron. Magnetic dipoles is a moment, so that we can write down the equation for the magnetic spin or magnetic dipole moment. So spin magnetic dipole moment. So this is the spin of magnetic dipole moment, and mu is equal to minus E by m and the s vector. So E is an electron, m is a mass, s is a vector. So this is spin on the magnetic dipole moment. So in this case, the mu is also related to the equation. Mu is equal to the EH by 4 pi m. So E is an electronic charge, A is this is for the constant. H is a constant, and also m is the part of the electron orbit can be substitute. So this is the equation for the magnetic dipole moment. Potential energy of the magnetic field. So the equation is minus mu into B. Mu is a permeability and B is a magnetic flux density. So that then you can also calculate the energy of the magnetic field. So U is equal to mu multiplied B. The current is this is for the this is the AD. This current to area is A. So in this case the current is flowing the I. So this we can produce the mu. The mu can also be calculated. Mu's orbit is equal to I multiplied A. Current multiplied area. Then you can also calculate this is for the magnetic U. U is equal to I multiplied A. So this is for the magnetic dipole moment of current loop. So magnetic dipole moment of a current loop. The magnetic material may be the diamagnetism and also paramagnetism and the ferromagnetism. So those are three magnetic materials. Each one is a magnetic material. There are three kinds of magnetic materials: diamagnetism, paramagnetism, and the ferromagnetism. Diamagnetism means that weak magnetic dipole moments are produced in the atoms of the material when the material is placed in the external magnetic field. So we place the material in the external magnetic field, it can only produce a very weak magnetic dipole moment. Paramagnetism means that magnetic field is produced when the material is put into the flux density, but as soon as the flux density is removed, the field will disappear. Ferromagnetism means that the magnetic field with magnetic materials, magnetism can be produced when you place the material into the magnetic field. But when you remove the magnetic field, the material still retains the sense of magnetism. So those are ferromagnetism. So the magnetic field partially passes when the external magnetic field is removed. So this is for the ferromagnetism. So diamagnetism means that when you put the magnetic field, produce a very weak magnetic properties. And paramagnetism means that it can produce a magnetic field so long as it is in the magnetic field. But as soon as the magnetic field is removed, so all magnetism will disappear. Ferromagnetism means that it can still retain a some amount of the magnetic field, magnetic property. So those are the three kinds of magnetic materials. So now that I am talking about the electromagnetic waves are traveling. So electromagnetic wave means that when the energy source we supply to the coil, so the electromagnetic current flow into a coil, so that this current will produce a magnetic flux. Those magnetic flux are traveling around the space. So those are the electromagnetic waves principle. So that those electromagnetic waves we can sketch the diagram. The traveling electromagnetic waves. So how many electromagnetic waves we can supply here is the energy source. So energy source is applied to the coil. So this is for the capacitor, and here is the inductor and the resistor. We supply the network. So this is we call the AC oscillator. So AC oscillator. So this coil we produce magnetic flux. So this magnetic flux are produced. So then this one connected to the outside external magnetic antenna. So this antenna So the antennas are magnetic flux are produced, the waveforms are produced like this. So electromagnetic waves are coming out. So this is we call it an SC oscillator, and this is a transformer. Here is a line, transmission line. The here we use an electric dipole antenna. So here we use a traveling wave. So this is the diagram of the electromagnetic waves induction. So that when we supply the energy, so that the LC oscillator produces electric energy. So the energy converted to the magnetic energy. So the magnetic energy, magnetic waves, they coming out from the electric dipole antenna. So those are coming out as a magnetic waveform. Those waveforms are spread around the space. In equation for the electrical voltage carried by the waves, in the meantime also magnetic densities carried by those waves. So we write down the equation E is equal to the E maxima psi Ka minus omega t. So this equation in the meantime B is equal to B maxima psi Ka minus omega t. So this is the equation that we can calculate. So K is a constant. K is a constant. E is the voltage, the B is a magnetic flux density. Write down the equation for the speed of the magnetic wave. The speed of the magnetic wave is equal to 1 divided by square root of mu0 into E. So mu0 is a permittivity, E is a voltage. So this is the speed of the magnetic wave. C can be calculated by this formula. So paradox of inductions are the EIF induced. So this is what is magnetic coil. So this is the passing through the magnetic flux. So when the magnetic flux is changing, so in this case voltage induced in the this is induced EMF. So the NEMF is induced in the loop. When the number of magnetic field lines step up to the loop is changing. So the NEMF in the loop is induced. And EMF is induced. In the loop when the passing flux is changing. So this is what is Faraday law. So when the electric magnetic flux, the flux are passing through the loop length. Properties of the atom. So atoms are they are stable. So all atoms form as any. So because atom can form as any solid or liquid or gas, they are stable. So atoms combine with each other. Each other means that we can combine the one hydrogen atom to oxygen atom. So this is the properties of the atom. So we can put the atom into systematically. So we can arrange the atom number across the with their ionization energy. So atoms emit absorb the light. When the atoms emit any voltage level is different, so the atoms emit or absorb the light. So those are the basic properties of the atom. So atoms are very basic for the nuclear physics. So now that we are introducing the nuclear physics, so before going into the nuclear physics, we are talking about the atoms. Atoms are stable, they can combine with each other. They are put together systematically in talking with the ionization of energy. So when the voltage level is different, so the atom can emit or absorb the light. In case of the we can summarize the classify the atom. That can be the metal, semiconductor, and insulator. So metal is semiconductor and the insulator. So depending on their resistivity, temperature coefficient, and density or the charge area. So they are we can arrange and classify the atom according with the metal, semiconductor, or insulator, depending on their resistivity, temperature coefficient or resistivity, and number of the density of the charge area, and also the so for example insulator is their charge density very high, but semiconductor is the positive and the negative charges. So those are the we can classify as atoms according with their temperature coefficient and charge density and the resistivity. Find as metal, whether metal is a conductor or semiconductor or insulator, depending on the resistivity. So for the insulator has a very high resistivity rho. Metal is a low resistivity, but the positive and the low coefficient of resistivity. Temperature coefficient of resistivity is a positive and a low. And also the last number of the charge area n. For the semiconductor, highs are rho, highs are alpha, and also the small number of charge areas are n. So this is what is the properties of the metal. So in this case, insulator got its highest band containing the electron is completely free and separated from the vacant. The metal is it can electron freely can move from the one component to the one atom to the another, one molecule to another molecule. So this is for the metal and the insulator. Right down an insulator here. The insulator, the highest bands are containing electrons are completely filled and is separated from the vacant band about it by the energy gap. So the normally this is for the vacant band free electron. So this is a nuclear. So this at the nuclear and the energy movement they are the energy gap. So this energy gap is a high energy gap for the insulator. But for the metals the atoms are the very ready for the lowest energy level. Lower energy level means the electrons are agitated either formally or electrically. So thermally or electrically, the electrons easily are coming out and move to the other places. So the energy level required to the agitated electron to coming out is the Fermi energy level. For the copper, the Fermi energy level is 7 electrons are 4. So we can also write down the electron in the partially free band. They are the conduction electron. Normally this is for the partially free band. So those electrons can easily move from the one place to another. They are the conduction electron. So we can write down their number, conduction electron number. Equation to calculate for the atom calculation. Number of the conduction electron in sample can be calculated. So number of atom in sample multiply number of valence electron by atom. So how many valence electrons are in the atom? So those atoms are really make the conduction. So number of conduction electron in sample can be calculated. Number of atom in sample multiply number of valence electron by atom. So number of atom in sample also be calculated. Sample mass divided by atomic mass. So the sample mass is the n sum. Atomic mass is the molar mass and divided by the Na. So number of the electrons. And so the material density multiplied sample volume V is the sample mass n. This is the molar mass and divided by Na. The density of the conduction electron. The density of the conduction electron is the number of conduction electrons in sample divided by sample volume V. So density state. So this is the Ne is a density state. Density state is 8 to 2 pi m power 3 by 2 the atom mass divided by H power 3, so H is a Planck constant, and this is body level, E power half. Occupation is a probability, so how much an atom can occupy the state can be calculated. P is equal to 1 by E power E minus ES. So E is the energy level. When you provide the energy, how much atom will be the electron can occupy can be calculated by the formula. Occupation is a probability. The formula is 1 divided by E power E minus ES. So E is the energy level, E is the Fermi level. Fermi level is the minimum level required to agitate the electron. Divided by KD. K is the constant, T is the temperature, absolute temperature. So in this case, the density of the occupied state can also be calculated. NOE is the density of the occupied state, NE, the density state, multiplied with probability, the PE. So the Fermi energy is the minimum energy required to agitate the electron or required to release the electron. So this is EA, the Fermi energy. So Fermi energy formula is 3 divided by the 16 root 2 pi power 2 by plus a squared divided by n into n power 2 by plus. So 0 by 1 to 1 a squared divided by n and n power 2 by plus. So this is n is the mass of the electron and n is the number of the parts. So depending on the number of parts, we can also calculate the Fermi level energy. Properties of the atom. So atoms they are stable. So all atoms form as any. So because atom can form as any solid. Three atoms each contain of the nucleus. So that nucleus is a combination of the electron, positive ion proton, and the next is charge neutron, positive charge electron, positive charge proton, and then this is a no charge neutron. They are surrounded by the electron. So this is what the nucleus of physics. So the nuclear physics we can arrange the nucleus. The force between the electrons and nucleus is we can calculate. So the force between the nucleus is the 1 by 4 by E0 into Q, 0 into Q, 2Q divided by D. So this is the nucleus of physics. So we can those nucleus are electrons. When you separate the nucleus, in this case, a lot of the energy will be coming out. So this is called the nuclear energy. So we can arrange the nuclear material according with their radioactivity and their nuclear properties. So especially the uranium is the best material to produce the nuclear energy. So now today I will give you the nuclear radioactivity and that force between the nuclear atoms and nuclear binding energy and nuclear energy level, nuclear force. Those are given to today. A 5 by 3 mega electron volt alpha particle happen by chance to be headed directly toward the nucleus of the atom. And now the gold, which contains 79 proton. So this is gold nucleus. Equal to the 79 neutron. So this is why alpha particle. They go inside the. But they are not touching because of they are called the force between them. So this is a mutual force between. So those forces we have to calculate. So in this case, we have to calculate for the energy. So K is a constant can be calculated. K into the alpha. So alpha particle the constant can be calculated. The formula is 1 by 4 by E0 into Q0. Q is a whole. Who is the AU? Atomic who is the AU divided by D. So this equation. So the D also calculated. So the point is D squared 2. So this is the Q0 into Q AU divided by the 4 by E0 into K alpha. So this equation. So Q0 we can calculate. Now there are 79 proton. So 79 proton. So this is what is Q0 is this is 2E. 2E multiplied with so 79 the proton is 79E. So 2e divided by multiplied is 79e, and divided by this 4 pi. 4 pi e0. E0 is 4 by e0. So k alpha. So this becomes as k alpha is becomes 5 by 3 MEV. Multiply with so 1 by 6. So 1 by 6 and you get 10 power. So 4 by E0 into K alpha. So that we can substitute as E. E means 2E, 2 multiplied 79. So E power 2 is equal to the 1.6. So 2E is 2 multiplied 1.6 into 10 power minus 19. Multiply with 79 with 79 into 1.6 into 10 power minus 19. Divided by 4 by E0. So K alpha magnitude can be calculated. This is a 5.3 mega electron volt multiplied with 1.6 into 10 power minus 13 joule per mega electron volt. So this is the value of the K. The whole thing is equal to the K alpha. So by solving this one, this distance is 4.29 into 10 power minus 14 meter. So the point is this alpha particle go into the hole so that before reaching the gold nuclear, it can reach up to 4.29 into 10 power minus 14 meter. Here is we can arrange the number here. This is for the horizontal line is a neutron number. So neutron number N and the vertical line is a proton number Z. The neutron number and the proton number we can draw the graph. So this graph is a we draw this straight line. So by this way we can arrange the nuclear properties. So in this case the nuclear properties are we can so I give you the graph here. And this is a neutron number. Neutron number is the N. So neutron number is 115 and the 116, 117, 118. 119, 120, 121. And this one is a proton number. The proton number is vertically 76, 77, 78, up to the 82. So we can draw a graph here. So we can arrange the neutron number here with this is the CS. CS, this is the OS like this. So this was the OS. So OS like this. In this case, this crossing line. Crossing lines usually crossing the platinum. So this is here we use the AU. This is gold. Here we use the platinum. And this line we use iodine, IR. And this is the titanium, T. So this is in this case, platinum is a very good nuclear property. So in this case, we get the proton number and the neutron number. Draw a graph, so if they follow the location is here. So this is for the location of the nuclear atomic charge. Nuclear rigidity. The nuclear rigidity can be measured by the unit. The photometer centimeter unit. This is the Fermi level. 1 Fermi, 1 centimeter. Equal to 1 Fermi. Equal to the unit, you can use the symbol Fn. This is equal to 10 power minus 15 meter. So this is for the nucleus rigidity can also be calculated. So this nucleus rigidity is any radius can also be given the equation. The radius I is equal to R0 into A power 1 time. So this is for the nucleus. So this is for the nucleus rigidity we can calculate by this equation. So in this case, the A is a mass number and R0 is usually 1 by 2 Fn. 1 by 2 into 10 power minus 15 meter. So this nucleus are very small. So this is the nuclear radius can be calculated by the equation R equal to R0 multiply E power R0 multiply E power 1 time. So A is a mass number R0 is 1.2 Fermi. Another one is atomic mass. So atomic mass can also be calculated. So atomic mass is the atomic mass unit. Atomic mass unit is 1.60 into 10 power minus 27 kilogram. So this is the atomic unit. Energy can also be calculated. C square is equal to 931,494 mega electron volt per unit. So this is for the energy produced by the each atomic unit. Can be calculated. The C square is equal to 931 megavolt per unit. So the atom mass means this is for the M minus A. A means that this is atomic unit. M is the accurate mass of the atom. So the difference is the atom mass. As the nuclear binding energy, so nuclear binding energy is a delta EBE. So this is a summation of mc square. M is the mass, is the light energy, light velocity, minus mc square. So mc square means the capital mc square. So this is for the nuclear binding energy. So we can also calculate for the nuclear binding energy. So nuclear binding energy is a delta EBE is equal to summation mc square minus capital mc square. M is the mass of the nuclear. The mass M of the nuclear is less than the total mass summation M of the individual protons and the neutrons. The binding energy per neutron can be calculated. So delta EBN. So this is the binding energy per neutron is equal to delta EBE. Delta EBE is the nuclear binding energy divided by A. A is the mass number. So this is the way that we calculate the nuclear binding energy and the radius of the nuclear. So the nuclear levels are energy level. Nuclear energy level is we can utilize the nuclear energy level, especially for the AL. AL is aluminium. So and maybe the higher. So nuclear spin and the magnetism. Energies are binding energy per neutron and the mass number is equal to the graph. Horizontal is the mass number A. And particularize the energy bar, you binding energy bar neutron. Binding energy bar neutron. So we can draw the things that this is for the 2H, this is hydrogen, here is the 6 and lithium, and this is for the 4 is the helium, like this. So those are the graph nuclear binding energy. All the atoms, we can put the other atoms, you can draw this graph. This is for the nuclear binding energy. So this is we call it this plot is a fusion plot. This plot is we can plot the mass number A and binding energy by the neutron. This plot is we call the fusion plot. Write down the nuclear energy level. So nuclear energy levels are we can plot the graph. Binding energy by neutron, the vertical line, horizontal is the mass number. So this way can this graph. So this guy we allocate the atom according with the energy level. This is we call it nuclear fusion. The nuclear energy level is we can write down the energy scale. Energy scale is a million of the energy electron volt. Million of the electron volt. So this is the energy level. Nuclear make the transition from the one level to another level, lower level. So in this case, it can produce the emit a proton. So this is for the nuclear. When the nuclear is at one energy level to go to another level, it usually emit a proton. So therefore, the proton emission needs to be controlled. So in the nuclear reactor, energy levels are changing from the one to another and emitting the proton. Three atoms are it contain of the nucleus.